G'day and welcome to the Powerful Learning channel. My name's Luke Rowe and I'm a learning scientist and university lecturer who specialises in evidence-based teaching in the science of learning. And in today's episode, we're going to be looking at the third instalment, the final instalment in our three-part lecture series on the science of successful learning. In this particular lecture, we're looking at the topic of mastering metacognition for learning. And really what it's all about, the success criteria, if you will, is to help our students become their own teachers and to give you the knowledge and skills to help you do that with your students. So I hope you enjoy it. If you do, hit the thumbs up, and if you want to have more content like this in the future, please subscribe to the channel. Thanks for listening. And this is our third and final installment in our Science of Successful Learning series, and I'm appreciative of your time, like Jennifer said, on a Friday. It's a big ask, and I've really been touched by the enthusiasm of others in participating in this. This one's on mastering metacognition for learning, and I guess the sub-focus there, the practical success criteria that I want you to walk away with, is how we can help our students to become their own teachers. Okay, let's recap on last episode, on our last lecture. We looked at the RIDE model, the 4 pillars of powerful practice, and the schema that we use, the mental model that we used to unpack that was with the RIDE acronym. Retrieval practice, and this was bringing information from long-term memory to the fore. So we have these mental models, our prior knowledge, and we're constantly externalizing that. Learning is characterized mostly by getting information out rather than putting information in. When we bring that to bear upon reality, only when there are violations of expectations can we correct those and update our mental models. So retrieval practice improves the storage strength of our memories, but also the accessibility component of our memories, which was equally important. Interleaved practice, the second pillar, was about mixing up our study and randomizing it to sort of mimic the randomization of real life. Life doesn't come at you in sequence, it comes at you in any direction. And as a result of engaging in interleaved practice, we are able to detect subtle categorical differences and discriminate between different diagnostic categories, different mathematical equations, different painting categories. So to the extent that our learning topics are easily confused between different categories, interleaved practice lends itself to improving learning and discernment in those spaces. Distributed practice is what happens after we've mastered the material initially, where we space our learning apart, right? And there's this kind of how long's a piece of string answer to how long we should space our learning apart. It's basically right up until the point where you can't successfully recall it. Right, so it's going to be different for different material. And as you get better at remembering the material and you've automated that in your memory and you've really laid it down in long-term memory, you can space your learning apart even further. So if a student's looking to commit something to lifelong memory and lifelong learning, then that's the way that you would go. You would go in incremental spaces over time, initial mastery, and then gradually revisiting the material over time in distributed fashion. Then we talked about expert practice. It's putting it all together like an expert. So we saw the Olympics recently with Tokyo, and I really loved the way that they portrayed, I think if someone could probably write in the chat, I think we got a medal in high jump with one of the ladies came, I think silver in high jump. And I just loved that she kept taking notes on her high jump about the angle of approach, her coach's feedback. Even while she was participating in her highest level of performance, she was taking notes on everything in a reflective journal. That to me was a picture of expert practice at play. And we can contrast that with the amateurs, right? So amateur high jumpers aren't going to be doing that. They're not going to be concerned about the effort, the attention to detail, the constantly having a voracious appetite to improve their weaknesses and gather as much information as they can from more knowledge, what Vygotsky would call more knowledgeable others, coaches, teachers, us. That's our job, that's our business, to help guide our students from novice to expertise. So that's our recap. That's what you missed out on last time in a 3-minute nutshell. What are we going to do today? Looking at 5 different aspects of mastering metacognition. We'll talk about why metacognition, so we'll foreground the rationale there. What is metacognition more generally? And then we'll zoom in on what it means for metacognitive learning, talk about some fundamental frameworks, not only for metacognition, but these are fundamental frameworks for how we learn how to learn. So that is another way to kind of characterize metacognition. And then we'll talk about tips for teaching and learning, and hopefully you'll walk away with something practical from today. But to foreground our discussion, I'm going to give you some case studies on metacognitive blunders. Radhika is a high school student preparing for her ATAR history exam. She's lucky, Jennifer's her teacher, but she relied on mass practice and rereading as it helped her feel familiar with the material. Despite feeling well prepared, Radhika did poorly on the exam and she cried. What happened? She was subject to the illusions of competence and metacognitive failure, where she favors confidence above competence. Right? If we have it in the other direction, confidence preceding confidence, that's all good. But when it's the other way around and we have a mismatch there, I'd take competence any day of the week over confidence. And she chose confidence as her primary source of information to inform her judgments of learning. She overestimated her learning and did poorly. We've got James, a university student who was preparing for his lab report the following day. After skimming his notes, he felt like he knew his stuff pretty well. So he packed up early, went out to dinner with his friends. The next day, he flunked his lab report. What happened to him? He had succumbed to poor cues and what we call poor metacognitive calibration. Rather than relying on objective facts to inform his judgment of learning, he relied on his distorted cues, such as intuition, and terminated study too early, rather than working hard when he had the chance to correct that record. And finally, an academic at an Australian university, which shall remain unnamed, and we'll call this guy Luke, is asked by the Associate Dean of Teaching and Learning, let's call her Jennifer, to give a presentation on powerful practice. Luke is very familiar with the content, so he wrongly assumes that he need not prepare and practice. He ends up including far too many slides and gives a masterclass in irony to his colleagues as it became clear that he failed to practice his presentation on, drum roll, practice. What happened there? That's the planning fallacy, and I fell under that spell. Underestimated my workload and overestimated how much free time I'd have in the lead up to it. This hypothetical guy did. So he failed to prepare and he missed the opportunity to practice his presentation on practice. Right, so in all of these cases, what happened was metacognition went missing. Right, the metacognitive voice inside was not giving us the guidance we needed in all of these situations. So hopefully that gives you a bit of a flavour of why metacognition is so important, because in its absence, we blunder our learning experiences. So here are 5 reasons why metacognition is so important to us as educators and to our institution. Reason number 1, metacognition helps with learning. And that's a really basic one, but we need to establish that as a foundation. It's a very foundational skill set. Flavel, who coined the term 5 years prior to this in 1976, he's mentioned it this way. Lack of hard evidence notwithstanding, I find it hard to believe that children who do more cognitive monitoring would not learn better both in and out of school than children who do less. I also think that increasing the quantity and quality of children's metacognitive knowledge and monitoring skills through systematic training may be feasible as well as desirable. And it's not just children, it's adults as well. We know that from recent research. There's a strong evidence base. So that's reason number 2. So we can be confident with the evidence. I point to a meta-analysis by DeBoer and colleagues in 2018 that showed a moderate to large impact on academic achievement. And what I found really fascinating about that meta-analysis that stood out to me was that the effect sizes when they did their meta-regression, their moderator analysis, actually increased in long-term follow-up studies. What's that tell us? That tells us that something's happening, something special is happening with students who get taught metacognitive skills and learning how to learn skills. They start to become their own teachers. Instead of giving them a fish, we're teaching them how to fish. And as a result, there's a snowballing effect on the academic learning that they're engaging in. Now, that's very unusual compared to other studies where you typically see the impact of an educational intervention drop off a cliff immediately after the intervention finishes, right? So there's a huge, unique benefit there to metacognitive training and skills because we're empowering our students to become their own teachers, giving them the keys to the car, and they drive their own learning. And John Hattie's work, his meta-analyses, which he incorporated about a dozen or so meta-analyses on this topic in the last 30 years, found a moderate to large effect there. And if we have any excuses at this point by saying, hey, it's all too difficult because it might be high impact, but it's too complex or it's too costly to implement, well, the Educational Endowment Foundation in the UK and the Evidence for Learning Group in Australia did a feasibility report on this and showed that it's one of the lowest cost, highest impact, and most well-researched or credible researched interventions in all of education. So it should be the low-hanging fruit with high impact for us. We have no excuses not to use metacognitive interventions in our educational space. It's also relevant to university students. Flavel originally started his work with children on literacy and reading and metacognitive skills for that, but it certainly branched out into the adult andragogical learning space. In other words, universities. And Creed and Phillips have done the biggest review into that and found a moderate to large effect there with college GPAs. So metacognitive skills are highly predictive of how students perform at university. If you want to Google that report, the guidance report, Sean Kang and I did that a few years ago, Metacognition, Self-Regulated Learning, and that's mostly for secondary and primary schools to engage in metacognitive interventions in their schools. Reason number 3, wide-ranging benefits. This is not just, like I said, not just about reading skills where it originated, but we know that metacognitive interventions and the learning how to learn skills are domain general. These can help in multiple different domains. They have differential impacts. As you can see on screen, this is from a 2013 meta-regression where they looked at meta-analysis, big effects, then they look at subcategories or domains of learning, and you see that there is positive impacts, pretty large effects, some extremely large effects on writing, reasonable on reading, maths, science, and other domains of learning. So we can't just say that this works for one domain or subject and not for another. Every subject that we know where metacognitive interventions take place, there is a benefit to learning. Reason number 4 is that metacognitive skills promote independent learning. And I hope that that is a goal that's shared by others here. I want my students to become their own teachers. John Hattie said it this way: the remarkable feature of the evidence is that the biggest effects on student learning occur when teachers become learners of their own teaching and when students become their own teachers. When students become their own teachers, they exhibit the self-regulatory attributes that seem most desirable for learners: self-monitoring, self-evaluation, self-assessment, self-teaching. The high impact teaching strategies document here in Victoria, which has been one of the pedagogical guideposts for our teachers here, said that in a sense, teaching metacognitive strategies entails teaching students to teach themselves. And I like this. I like this idea that one of our primary goals as educators is to make ourselves redundant, not in a employment sense, but in a functional sense of giving our students the ability to teach themselves. Rawdon and Loka said it this way: the most effective teaching eventually makes the teacher unnecessary. Students will succeed to the extent that they become independent lifelong learners who have learned from us, but no longer depend on us to learn. Giving them metacognitive strategies and skills, the capacity to teach themselves, will achieve that end. Reason number 5, metacognitive skills promote higher order thinking. So metacognitive thinking is a type of higher order thinking, and in a conversation with a wiser, reflective, and more knowledgeable self, it is the ultimate inner teacher. I think Einstein was aware of this. The world that we have made as a result of the level of thinking we have done thus far creates problems that we cannot solve at the same level we created them. I think there's more simplified misquotes of that statement, but basically what he's saying is all the wicked problems around us can only be solved by a level of thinking that is a higher order than we created those problems with. And as a result, we've got to tap into our metacognitive selves to have that higher order thinking coming to bear upon those wicked problems. So there's the 5 reasons, but we haven't really got into this idea of defining metacognition. Right, so I want you to think for 10 seconds how you would answer that question. I'm sitting here, we're in a tutorial together, and I ask you to turn to the person next to you, define metacognition. So I want you to think of that. You could be bold enough, write that in the chat. I'm not going to be monitoring the chat because it threatens derailing the recording, but I'll trust that you're having that lively chat discussion there. Now, when I ask my students to define metacognition, they'll often say this: metacognition is thinking about thinking. And if they say that, I'll say, okay, that's a good starting point, but I'll give you a B minus. Right? So we're not quite there yet. We want to be able to extend and elaborate on this definition. And hopefully after today, you'll be able to enrich your understanding and get that A+ definition by the founder, Flavel, 1976, when he first coined this in a book chapter. The active monitoring and consequent regulation, those two aspects are crucial. Monitoring, regulation, and orchestration of these cognitive processes in relation to the cognitive objects or data on which they bear, usually in service of some concrete goal or objective. That gets you an A+. Now, a chief goal of education is to teach our students how to think rather than telling them what to think, and this is a fundamentally metacognitive endeavor. So really, I think that the overarching approach here is to teach our students how to think. Metacognitive skills and all the rich research we can draw upon for that will inform us how to do that. When you look into the literature and you dive in a bit deeper, you'll see that there are sub-dimensions of metacognition. And when we looked at a review by Scott and Levi in 2013, they came up with 5 components. They were trying to be a bit more careful in how we define what they called the fuzzy concept of metacognition. And they said knowledge, monitoring, planning, control, and evaluation were the 5 components. However, what I will say is this: when you actually start to do things like factor analysis and more empirically rigorous studies on any sort of metacognitive intervention or exploratory study there, you'll start to see all of the data converging into the monitoring, the control elements. Everything else tends to be absorbed into those 2 categories. They are the primary categories. That's why they're in red. So that's Scott and Levi's discussion there around those 5 components, but they also have different points of emphasis along the learning cycle, right? So certain aspects of metacognition are more important in the before, during, and after phase of learning. Zimmerman said it very well when he talked about the notion of self-regulated learning. He had a model about planning, performing, and pondering, right? The 3 Ps, before, during, and after learning, always reflecting on how you can get better at each of those stages. We'll focus on the monitoring, regulation / control elements here. So the simplified model, I want you to sort of build into your own mental model and your own metacognitive model of metacognition, is just thinking about the monitoring and the control aspects. So Thomas Nelson and Louis Narens, who's no longer with us, but they were absolute heavyweights in this space, and they really did take the notion of metacognition from Flavel and put it into the harder science domain, and it's certainly part of cognitive neurosciences now, and is a very mature construct in the field of psychology and cognitive science. The pieces to that puzzle that tend to stand out most: monitoring, ongoing awareness of knowledge about and reflection upon cognitive processes, and the control elements, actively modifying cognitions and regulatory behaviors based on monitoring outputs. Here's the model they used. You can think about it as a bit of a toy model, but it's a good starting point, right? So this is our foundational model, and we can put branches on the trunk of that tree later. They talked about the cognitive processes are split into 2 or more specifically interrelated levels. So you've got your thinking on the bottom level, and what they call meta memory, and we now call this metacognition at the top level. So the meta level contains a dynamic model, an ever-changing, updating model. So we talked about this idea of the Bayesian brain, where we made mental models of the world, and now this is about making models of our own thinking and ourselves as learners and our own knowledge, right? So it contains a dynamic model, a mental simulation of the object level or our cognitions. And then you've got these other 2 levers, right? So there's the 2 big pieces, the metacognitions, the cognitions, and then the 2 levers of information flow between, right? And there's the monitoring aspect, the 2 dominance relations called control and monitoring, which are defined in terms of the direction of flow of information between the meta level and the object level. So that's the fundamental schema that we're going to build on now. And really what it's saying is, it's really talking about this idea of the subject becoming the object. We become the object of our own insights, our own reflections, and our own cognitions. So when the learner themselves, the subject of the thinking process, becomes the object of their own reflection, they're engaging in metacognition. And I think it's worth just reflecting on how ridiculously amazing our brains are to be able to achieve this. And sometimes in this space, I get so caught up in the science and, trudging away through papers that I forget there's actually a bit of magic to this. And I think I can't summarize it better than to say that this is making the incomprehensible comprehensible. And I love this quote by the late and great Donald Davidson, an American philosopher, who said, there are three basic problems of mind he was referring to. How a mind can know the world of nature in an orderly sense, how it is possible for one mind to know another mind, which is what we're engaging in now, and how it is possible to know the contents of our own minds without resort to observation or evidence. We can look and peer upon ourselves as an observer of ourselves. Just think about how special that is. Now let's zoom in. We're going to look at what metacognitive thinking looks like insofar as it relates to learning. When we talk about it in that sense, we're talking about learning how to learn. And this is why we start to say that metacognitive skills allow our students to become their own teachers. And so I've adapted the Nelson-Narens model into a learning how to learn model, essentially. And Nelson and Narens, instead of the metacognitions at the top, these are the learning how to learn skills, or what they called the metacognitive library. This is a mental library replete with learning strategies, self-teaching strategies, strategies for seeking help, strategies for knowing when, why, and how to implement different learning strategies. Then at the bottom, the cognitive levels, the actual task execution, the knowledge and skills required to complete a learning task. And of course, we've got monitoring and regulating or controlling our own learning. So it's the same thing, just adapted to learning. And just to make it a bit more clear, let's compare and contrast the student who's engaging to your left of screen in cognitive learning processes compared to the student to the right of screen who engages in metacognitive learning. Right, so the student in cognitive learning is going to be reading the text to understand it on face value, whereas the student who's engaged in metacognitive learning is purposefully reading that text to clarify points of confusion, answer questions that they're bringing to bear upon that text. Student who is solving math problem is engaging in cognitive learning, but then there's the student who's engaging in the metacognitive learning who's double checking, measuring twice, cutting once, so to speak. They're looking at alternative strategies to corroborate their original solution so that they can be doubly sure that they've got the correct answer. Again, becoming their own teachers, not waiting to submit the work and get the answer from the teacher. They're correcting themselves. And then, of course, you'll be familiar with this one, students submitting their assignments and waiting for the teacher to mark their work as if they're powerless over understanding their strengths and weaknesses, whereas the metacognitive learners, they're going to be self-assessing. They're going to get the rubric out before the assessment is due and mark their own draft as if they were you marking their work, and they're going to write comments on it about what they need to do and what they need to improve, and they're going to correct accordingly. Right? So they're becoming their own teachers at that level. Now, I like the Kipling's 6 Honest Serving Men. So Rudy Kipling, a poet, an author, The Jungle Book, if you've ever read it, he was the author of that and many children's books. Fantastic writer. He talked about the 6 honest serving men, which will foreground a model I'm about to help you dive into. And in this poem of the 6 honest serving men, he said, I keep 6 honest serving men. They taught me all I knew. Their names are what and why and when and how and where and who. I send them over land and sea. I send them east and west. But after they have worked for me, I give them all a rest. And so I think this is a really helpful mental model or heuristic to help our students build their metacognitive library. Right? So you can say, how are we going to build our metacognitive skills? Well, ask your students to ask themselves about the 6 honest serving men of Kipling's poem. What learning strategies should I use? Why choose a learning strategy over another? So being able to justify one choice over another. Where should I study to optimize my learning? This is a good one when students have got headphones in, there's lots of busy traffic. Some students like that atmosphere and they're more productive there. There are other students who need silence, who need to find an environment that's more conducive to what optimizes their study. When should I change my learning strategy? We know that mass practice, we talked about this last time, mass practice is really good for initial acquisition of knowledge and skills, but it's not so good thereafter, right? Once initial mastery is acquired, we start to distribute practice. So we go from the initial acquisition phase, master the concept, reach that success criteria, and then we should transfer from massed practice into a spaced out or distributed practice mode, right? So knowing when to use different strategies and when they're most and least effective is really important. How can I improve my use and range of learning strategies so that we're not just attacking things with one way of solving things? Students who have multiple ways of solving the same problem, and I gave the example with mathematics before, they tend to have more probability of success because they've diversified their learning strategies there, so that if one strategy gets stuck, they've got a whole repertoire of others to draw upon. And then the final one, and this is where talk about this idea of independent learning as if we're islands unto ourselves. But no, the metacognitive learner is able to recognize their own limitations and engage in help-seeking behaviors at the edges of their limits. So they can do what Vygotsky said and build a bridge between their zone of proximal learning and going beyond that with the help of a more knowledgeable other, a teacher. I guess, how do we measure it? So if you want to measure this in your classroom, there are plenty of ways to measure metacognitive practices and metacognitive behaviors. The self-report questionnaires, they are by and large the most popular, partly because of the nature of this. I would say self-report is often an unreliable way to get at a latent construct such as metacognition, but the very nature of metacognition is an introspective thing. So I think in this case, it's more valid than many other constructs, scientific constructs. So self-report questionnaires can be very helpful there. Think aloud protocols, right? So what's this mean? This means that when your students are engaging in different practices in your classroom to acquire or demonstrate to you a skill or their knowledge, get them to commentate on what they're doing and explain to you as they go what they're doing. So you're peering into their mind by asking them to externalize their inner voice, their inner dialogue, and that way you can start to see their thoughts or hear their thoughts out loud. Structured interviews, so you can ask prompts, do you double check your work? Do you, seek help when you recognize your own limits? There's different ways to gauge students' metacognitive practices and habits there. Observational checklists, same sort of deal. We'll get stuck into student judgments of learning later. Micro-trace methodologies. Instead of spoken and externalizing your learning and your thinking in spoken form, you can also do that in written form. So micro-traces are margin notes, Cornell notes, if you've heard of those. This is essentially asking yourself questions while you're reading along the way. So elaborative interrogation is another way to put that. Student diaries and reflective journals. ACU does a lot of that. I think we're really good at that practice in having assignments where students do the work. I know certainly with a lot of my students, we do lesson planning, we do assessment building, and then we get them to provide commentary or annotations on the side. And that gives us the ability to kind of peer into their mind so that they justify their thinking. So we're not just looking at the product of their thinking, but the process in how they got there. And then, of course, brain scans, and certainly your prefrontal cortex, the higher order executive functions are coming to bear upon metacognition. It is a higher order skill set there. And so there is a developmental impact on metacognitive skills. Certainly, if we go into the developmental literature on metacognition, you can still have metacognitive skills and developmental features very early on, 2-3 years old. But students don't start to understand their memory processes and their capacity to forget things until about 4 or 5 years old. Thereafter, they're very ripe for teaching them about how to monitor and regulate their own thinking. So they just have to put it into a communicative form for children at that stage. So early childhood educators who are here, metacognitive skills are really important. I also want to shout out to primary school teachers and early childhood educators, because I think they're actually miles ahead of other types of educators in think aloud protocols and explaining their thinking and having students do that. You see at early childhood education centres and kinders and primary schools, teachers are often externalising their thinking and telling their students, all right, we're going to open the book and we're going to follow the page. We're going to follow the letters with our finger because so we don't lose track and get distracted. We're going to sit in a quiet corner. So they're externalizing and justifying their thinking. They're very good at it. We lose that in high school, and certainly we don't do that in tertiary settings. So I think there's some advanced ways of demonstrating metacognitive skills in our teaching practices there. These are questions, a sample of questions from the Motivated Strategies for Learning questionnaire, which is the #1 or most popular survey for or questionnaire for metacognition and self-regulated learning skills. So have a think about that and whether that's true of you. That would be a 7. or not very true of you, which will be a 1. So if you were to ask yourself on a Likert scale like that, I believe I will receive an excellent grade in this class. You say very true of me, that's a 7. I usually study in a place where I can concentrate on my coursework, that would be a 7. When reading for this course, I make up questions to help focus my reading. So again, this is the sort of metacognitive practices that you can pick up in a survey like that. It might be informative for your students to reveal some weaknesses that they can capitalize on and strengthen throughout the semester if you give them those surveys, which are publicly available. Metacognitive learning, expanding the monitoring and control framework. So we had our toy model. Those 2 pieces from Nelson and Narens, the metacognitions coming to bear upon the cognitions, with the monitoring and the regulation as the 2 levers between them. Now they've expanded on that. I don't want to information overload you, but there's 9 little pieces that they've looked at in different paradigms for measuring, monitoring, and investigations into metacognition at different phases of the study, of the learning sequence. So at the acquisition, retention, and retrieval phases. We won't have time to go through all 9, but we'll go through a couple of these now. Feelings of knowing, otherwise known as FOX, as in phonemically fox in socks. Don't want to offend anyone if you're Scottish here, but yeah, FOX paradigm, FOKS. This is a feeling of knowing test that I've grabbed from one of the earlier studies on this. I'll go through it with you. So if you're well traveled, this should be easy for you. If not, maybe not. So I want you to recall the capital of Morocco. All right, so don't say it out loud. This is just a personal thought experiment for you. And if you can't say the answer to yourself, just tell yourself can't recall. So this would be you sitting in my experimental, in my room, and I'm asking you these questions. If you say can't recall, the next question I would ask you is I want you to judge your feeling of knowing from 1 to 6 on a Likert scale. 1 is I definitely don't know the answer. 6 is I know the answer, but I can't recall it at the moment. So you've got a strong feeling of knowing, or a weak feeling of knowing, or a feeling that you just don't know at all. So that's your feeling of knowing rating. And then I'd show you, for those of you who couldn't answer it in the first place, a recognition task. Right, so not recall anymore. We've moved to recognition where there are cues. And of course, you would say B, rabat. And if you had a strong feeling of knowing, at 6, 78% of you would have got that correct, right? If you had a weak feeling of knowing, maybe 30% of you still would have recognized it, but certainly not as much as of those people who had a stronger feeling of knowing. So what's this telling us? It's telling us something very unique. When an item could not be recalled correctly, the feeling of knowing rating that we did in step 2 predicted the likelihood of correct recognition along a gradation of knowledge. And that is super important because knowledge is not just discrete, we know it or we don't. There's actually a gradation of accessibility to that knowledge. You might have the answer tucked away in a little box in your memory there, but you've got to wade through all of the layers of cognitive interference to get there, right? And you might know that you know it. Really, somewhere in there, and the frustrating part of that is you can't access it at this point in time until I give you extra cues to prompt that. Right, so there is a gradation, and this is really a validation of the construct of metacognition, right? Because we know something, and then we know something, but can't actually access it. A special case of this that we've all experienced before, it's called the tip of the tongue phenomenon, otherwise known as the TOT paradigm. And so when we talk about metacognitive judgments, I'm going to try and induce that in you using some of the original questions from the research on tip of the tongue now. So I want you to see if you can recall a navigational instrument used in measuring angular distances, especially the altitude of sun, moon, and stars. Might have a word in mind there. Don't go Googling that. What's the word for favoritism shown to a relative? A little easier there. What's the word for a group of witches? Okay, so you might be getting a tip of the tongue. I know this, but I just can't show this. Sextant or backstaff, nepotism, and coven are the answers there. And hopefully, if you had the tip of the tongue feeling, and I set you up for that, and I mean, it's hard to induce that in a group of academics because they're often knowledgeable enough to have this readily accessible. But for a lot of people, That will induce a tip of the tongue phenomenon. And then they'll get this sense of magical relief when they see the answer. They're like, yes, that was it. That's what I was thinking of. And often it can be such a strong tip of the tongue, or such a strong frustration, that you can describe the word. You can say what letter it starts with, but you can't actually speak the word, right? So there's a retrieval access blockage, a retrieval failure, not an actual storage failure of knowledge, but a retrieval failure. And Brown and McNeil talked about this in relation to their participants when they brought that tip of the tongue phenomenon paradigm into their research. They talked about their participant, one in particular, is seized by a tip of the tongue state. The signs of it were unmistakable. He would appear to be in mild torment, something like the brink of a sneeze, and if he found the word, his relief was considerable. You know it, but you just can't show it. And hopefully this is not what happens to our students in their exams. If they're getting this in their practice exam where they're starting to get retrieval blockage there, what you need to do is you need to tell them that they've not only got to store the memory strongly, they've got to practice retrieval enough so that the retrieval strength, the accessibility pathways are strengthened. And that's why retrieval practice is so powerful. It's not just about entrenching a high fidelity memory in our minds. It's making sure the access pathways are very well built and strong as well. So the implication, do lots of practice tests, lots of practice essays, lots of practice performances so that you've got the retrieval pathways wide open. Now, here's another paradigm here called the judgment of learning paradigm. And I want to kind of contextualize this both in metacognitive failures for students and for teachers. And this one hopefully is reassuring for us. So there was a study by Shana Carpenter, who's an absolute rock star of the learning sciences. Love her work. Google her and look at some of her papers if you're interested in the learning sciences. She did this study where she asked randomized participants into two big groups and had pre-recorded lectures on a particular content piece that was obscure to the students involved in this or the participants involved in this. So there wasn't any confounding by prior knowledge, right? So they spend 5 minutes watching a lecture with a person who's speaking fluently, very fluently, upright posture and confident. Then the other people who are randomized to the other condition are watching the exact same material, so scripted exactly the same by a person who's sitting down and or blurred screen with disfluent language, right? So broken English, but the same words, but disfluently delivered. Now, when Shana Carpenter and her colleagues asked the students to rate which of those experiences that they learned more from, to predict how much they learned from those 5-minute lectures, what do you think they rated more highly? Well, of course, if you said they rated the fluent speaker as the more beneficial speaker to their learning, you'd be correct. That's what they predicted. But guess what actually happened objectively? So when they actually looked at the objective results of assessing the students' knowledge on those two juxtaposing conditions, the students, they had a massive overconfidence effect in predicting how much they would learn from the fluent speaker. And that's the darker grey to left of screen. But then about half of that is what they learned. So they predicted they were going to learn or correctly recall about 50% of the quiz questions, but they only got about 25% correct. Then to the right of screen, the disfluent speaker condition, the students weren't overconfident. They predicted they were going to get about 27% of the questions right. They got about 23 to 25% right. So there wasn't overconfidence there. What you're noticing here is about an equal or equivalent recall for both conditions, right? So all of the social lubricants of a fluent delivery and a confident speaker aren't actually that important for learning. And they can even throw a student into a state of what we called before with our case studies, an illusion of competence, right? Where the fluency induces a sense of confidence in recalling the material. And as a result, they don't study as hard, right? So there can be a real downward effect for the overconfidence of a speaker like that. Not to say that we should do the opposite, of course. Right, but I think the key here is to tell our students about these metacognitive biases where your predicted learning outcomes can differ massively from your actual learning outcomes, and to know what situations will induce that, and what some people have referred to this situation as is the halo effect, where the speaker woos you and into a false sense of confidence in the material they're speaking about. And because they're all polished in their speaking, you tend to rate your own benefit from their speaking as higher than a situation where it's actually not, in fact, the case. So, but students aren't the only ones who get it wrong, right? We know this. So we're students of our own craft as well. I want to ask you a question here. How effective are you at giving feedback to improve learning with your students? Now, this is bread and butter for us, right? We should be pretty good at this, I think, as educators. But 10 is you're excellent. 1 is you're terrible. Right, so think about this. You don't have to put it in the chat. Just your own personal thought experiment. How would you rate yourself? The next question I've got for you is, how would your students rate your feedback if I was to ask them the same questions? Right? How would they rate the feedback you're giving them on their assessment tasks? Now, I looked at this study as a way to humble us as educators. Right? When our judgments of learning get it wrong, and there was a group of surgical interns who were learning from the key surgeons and about how to perform their surgery. And when you ask the surgeon who was teaching the surgical residents how to perform the surgery, did you give good feedback to your surgical residents? 91% basically felt that they were often or always successful at giving effective feedback, whereas only about 17% of the surgical residents agreed with them. Right, so there's a massive discrepancy here in what John Hattie and Helen Timperley described as feedback given not equaling feedback received. Right, so feedback given does not equal feedback received, and we can metacognitively delude ourselves into thinking we're hot stuff, we're great teachers, we're giving the best written feedback, we're almost writing as much of an essay in commentary on the students' work as they wrote in their original essay themselves. Right, so feedback given is not feedback received. If you buy into that transmission model, you'll assume that as educators, and we're all guilty of this, I'm certainly guilty of this, is that I look at the students' work, I write down the feedback as I'm reading down their essays. There's all sorts of annotations and commentary. Then I'll give a nice written piece at the end, or I'll do a recording for them, and I'll send that off to them in the hope that they're going to listen to my wonderful words of wisdom, take that on, and go forth into the future as a better student as a result. But then the crushing thing is, I go and look at the activity logs of my students and see how many of them have checked my written feedback, and my world comes crashing down as I realize about 15 to 20% actually look at my written feedback. How are they going to have traction with my incredibly wise words if they're not even looking at it in the first place? So what do we have to do? We have to overcome our metacognitive tendencies to assume knowledge and build into what our feedback practices, what Carlos talks about as a sustainable model of feedback. Giving feedback, but then seeking feedback on our feedback from students. You know, we should be asking our students, what's the best way to give you feedback on your essays? Because I'm noticing there's only about 70% of you who are checking your written feedback, and I'm spending a lot of time writing those comments, but it's clearly not the best way to reach you. How can I be better at reaching you with my feedback? Right, so getting feedback on your feedback is the key here. And I've got a colleague from my previous university, Luke Rowe, talks about this as feedback capital, feedback squared, checking your feedback, building the ability to get feedback on your feedback, and having students give themselves feedback as well. There's another paradigm here in a Judgements of Learning framework that I think can be helpful to us. But before we dive into that, I think we've got enough time for this one. I want you to rate your own knowledge on metacognition. On the topic of metacognition, on a scale of 3, 0 to 3, would you rate your knowledge as 3, excellent, or 0, non-existent? Hopefully after this first half an hour, it's somewhere in the middle if you started off as non-existent, but give yourself a bit of a rating. You don't have to put it in the chat. Just think about where you'd rate yourself. And now we'll quickly do a quiz. I want you to answer this question to yourself. Keep tabs on your score. Give you about 5 more seconds. Okay, it's A. That's the answer there. I've got a couple more questions for you. Give you 5 more seconds. There you go. B. Last question. This one's a little more difficult or controversial, but the catch there is metacognition. Metacognition and think aloud protocols are not just modeling the behavior, it's the explanatory speaking out loud as you engage in the modeling itself. All right, so think about what just happened there. We gave you 3 questions. I asked you to rate your knowledge out of 3. Did you get all 3 questions correct? If you rated yourself as 3 out of the scale that we gave you before, the excellent knowledge on metacognition, if there was a difference there, you've got a prediction error, right? And so this is what we can do with our students before we engage in the assessments. One of the things I do at the beginning of semester is I say to my students, we're going to engage in a metacognitive prediction task. I want you to sit down and pair up with someone and go through the rubric of our first assignment and predict your actual score on that assignment. Then I want you to zoom in and actually mark along the rubric where you stand on each criterion. So they've marked themselves in advance, just imagining their future self submitting that assignment. What score are you going to get? The score out of 100% is what's called an absolute judgment of learning, right? And that's the absolute judgment of accuracy. And if they get 100% and they predicted 100%, we say they're perfectly calibrated with their absolute judgments of metacognitive judgments of learning. Then we can talk about the idea of a resolution judgment or a relative accuracy judgment, where we say, okay, you only got 70%. Where did you fall down the most? Which criteria are you weakest at? Right? So there's another degree of detail that's required in your metacognitive judgments of learning to zoom in on that level. And you ask students this in advance, both predicting their assignment scores at the beginning of semester. And then the trick is to do this again once they've submitted the work, these 2 questions. Okay, now that you've submitted the task, and I'll give it back to you in 3 weeks, according to our policy, what would you rate yourself? And often you'll see the scores come right down. And so they've over-predicted, they're overconfident in what they thought they were going to get at the beginning of the semester. Reality kicked in, their time shrunk into all of these late nights or early mornings. And as a result, they haven't done as well, and they're more acquainted with the details of their failings and foibles there. So as a result, they'll mark themselves lower and get more closely calibrated, because often they'll get the assignments coming back closer to what's called a postdiction. So after they've done the work, but before they've seen the results. Right, so this metacognitive skill of calibrating has huge implications. The absolute accuracy judgments are the judgments, the primary things, the primary mental cues that we use to make judgments of how much study time we should devote to a particular topic, right? Am I going to get a 70 out of 100? Great. I'm going to back off and go to that subject. Now I've done enough to get through that unit. I'm going to go and study another subject that I think I'm only going to get a 40% for in the assignment. I've got to get it up to at least a 50 and perhaps a bit of breathing space, a 60% before I stop studying that particular subject. So students make all of these metacognitive judgments. You can see that they have high stakes implications there for them if they get this wrong. And the way to fine tune that, of course, is, okay, I'm studying to try and bring my scores up from a 40% level of knowledge and skills to a 60% level of knowledge and skills. Where do I begin? And this is where we go to right of screen on a resolution judgment. And we start to say, where am I weakest? Where, if I was going to mark myself on this assignment right now, which criterion am I going to suffer most in? That's where I need to start first, because that's where I've got the highest ceiling of improvement, right? So you can start to inform your judgments of learning and regulate your study with those judgments and the monitoring of your own learning. So you see how important these judgments are in terms of implications for our students. And there's a study there by Dunlosky and Metcalf. It's from a book behind me here. Got this book a while ago, highly recommend it. It's very creatively entitled Metacognition. It's a 2009 book. I bought it, I think, in 2010. I've revisited it many times, but it's got a lot of pioneering research in there. One of those is talking about how students' predictions and postdictions start to get closer to a higher level of calibration or more accurate calibration as time goes on with their studies. So these cues that they're using, they're starting to use objective cues to inform their learning. What you'll also notice down there, and those of you who are have been ensconced in this literature in the past will understand that this points to what is often referred to as the Dunning and Kruger effect, which is now called into question. There's a few people who think that is a statistical artifact as a result of people, ceiling effects and regression to the mean and statistical noise. But essentially what that means is higher ability students tend to have a more accurate judgment of learning than lower ability students. All right, so that's the idea, and they called it I think the double curse of unconsciously incompetent. So they didn't actually know that they didn't actually know that much. Right? And they talked about it as a double curse because they don't know in the first place, and the secondary curse there, they don't even know that they don't know, so they don't regulate their study accordingly. And that caught on as a bit of a meme, a cultural meme. But again, I call it into question. There are some really big players in the field of science of learning who are challenging that idea of Dunning and Kruger effects. Certainly the overconfidence effect is still robust. Now we can turn to Aristotle here and say, all I know is that I know nothing, but we should have asked him, how do you know that? And I think this is important because it taps into this idea of what informs our metacognitive judgments of learning. And one of the leading hypotheses, there are several, but one of the leading ones here that I think is most helpful for today is the Cue-Utilization Hypothesis. And this is essentially saying that our metacognitive judgments are anchored around different types of cues that we use to inform those judgments. That can be familiarity, or in the case of the lecturer who spoke fluently, a sense of fluency and ease by which we comprehend and encode and process the material, or even our recent results, right? We might have results from a recent exam and we're starting to use our judgment of learning by anchoring it on that recent result. And, that tends to be an objective way to inform us. And so the strengths here is that this theory or this hypothesis can explain both misinformed and informed metacognitive judgments, right? So it can say that we can get misinformed, say, for example, the case studies of metacognition gone missing, where we had people using their intuitions, their feelings, right? Their feelings that are not properly calibrated. And so they're using subjective guideposts as a heuristic or a marker or a cue to guide their learning judgments. And that's a fraught exercise unless you're very well calibrated. For most of us, we need to bring our subjective cues under the authority of objective cues by testing those subjective feelings and saying, oh, okay, I feel like I know this topic really well, but I'm going to actually put that to the test by speaking to somebody else and testing my knowledge and seeing if I can have a high-level dialogue or defend my ideas against the scrutiny of a more knowledgeable other. Or it could be the other way around, where I've got myself testing myself with a quiz. So I guess that's the idea. Seek objective insight on subjective judgments. I'm going to skip through this and go to my 3 tips, and we'll call it a day. So I want you to engage. I just talked about engaging in prediction and postdiction with our students, right? So when you start a semester, use that as that key opportunity to ask your students to make a prediction about their assessment scores, their exam scores. Get them to write it down in some kind of reflective learning journal. And then once they've submitted that assignment or done the exam, get them to have a second moment of reflecting on how they'll do. And they'll start to understand themselves as a learner, and they'll be able to profile themselves as a learner more accurately. The next one is to externalize our thinking. And there are 2 paths that we can use to do that. I talked about think aloud protocols and any way of externalizing our thinking verbally. So having our students explain their thinking to us to demonstrate their knowledge and skills, rather than just using inference of their performance as a way to see if they understand what they're doing. But also written artifacts, what we call micro traces, so artifacts of learning. Having your students annotate and explain each step of the way of how they're arriving at a solution to a problem. Also talking about the process of putting together an essay. It's not just I looked at ChatGPT and asked them to give me the key structures and what is going on in their own thinking here. Can you build an assignment to help them externalize that so that you can have a look into a view into the machinations of their mind in that learning process. And then, of course, there's metacognitive feedback, which is feedback that's not just results-based. It's not just outcome-focused. It's feedback on developmental pathways to improving, right? I'll go to this one here. Got metacognitive feedback. They're the 3 questions. If you're engaging in metacognitive feedback, instead of dumping the answer on our students, help them. If you've achieved your goal with metacognitive feedback, they should be able to answer these questions, and so should you. Where is the student at right now? Where are they going? Where's their learning goals? Where do they want to end up? And how will they get there? Right? So those 3 questions should be the guideposts of metacognitive feedback conversations with our students. And this is where the Carlos model, the sustainable model, checking that they know the answer to these questions. And once we do that, we can be assured that we have a mutual understanding of where the student's at, where they should be going, and how they will get there, the strategies along the way, the metacognitive strategies. And that's how we can give them the gift of becoming their own teacher. There are 3 stakeholders who can engage in that. The teacher can do that. We can do that with our students. They can do it with their peers and ask those 3 questions, or they can do it with themselves. Where am I at? Where am I going? How will I get there? I'll finish on this one. Descartes said, cogito ergo sum, I think, therefore I am. But I've modified this with an addendum. Metacogito ergo disco, I think about thinking, therefore I learn. So I hope you've done plenty of that today, and I will finish up. Stop sharing my screen and we can go to some questions. Otherwise, if you have to get away, thank you so much for your time. It's been a privilege.